All right, hello everybody. Welcome to class today. Today we're going to go over the distributive property and we're going to take a geometric approach to it. So, first we're going to go review some information about unit squares and areas, things like that. So, a unit square is when the dimensions are 1 and 1. Remember that a square has 4 right angles and 4 congruent sides. So a unit square is just if there's one, if this is one unit and this is one unit, then we say it's one square unit. And in this case, the one wasn't specified, but if this were a meter, for example, 1 meter and 1 meter, we'd say it's 1 square meter. And using that same principle, we can see that if we have 2 units on the vertical side and 3 on the horizontal side, that'll give us a total of 6 square units, and I drew in the squares so you can see that. So all that is just the area of a rectangle, which is base times length. And I showed another example for the 3 times 5, that equals 15 square units. So it works in a general case where the length is y and the height is x, it's still going to be xy square units. So the reason that's important is because that helps us with the approach we take to the distributive property. Remember that the distributive property says that that's what it says. That's actually a really powerful thing. So it might be helpful to just use numbers first so you can see, you get a hang of how it works. So for example, if we have 3 and one second. If we have 3 and, for example, 4 plus 5, it would equal 3 times 4 plus 3 times 5. And if we have 4 times 8 plus 2, that would equal 4 times 8 plus 4 times 2. So that's what the distributive property is saying, is that instead of adding these and then multiplying it, you can kind of distribute it to each one. And I'll show a geometric kind of interpretation to it. Switch papers real fast. Okay. I have that paper. Okay. So when recall how we had the area shown. So let's just draw an arbitrary rectangle here. And if this is 2 and this is 4, and let's say this is 3, right? There's 2 ways to think about this in terms of finding the whole area, right? We can add this rectangle plus this one, the shaded plus the white, to get the whole thing. And I'll outline the whole thing so you see what I'm talking about. This is the whole thing right here. There's 2 ways to go about finding the area of this. We can either do 3 times 2 plus 4, which is 6, right? And that gives us 18. And that would be when I take this as the length, as the vertical height, and this as the horizontal length. Or I could think of it as adding it part by part, because the sum of the parts of the whole. This thing plus the white thing equals the whole thing. So looking at it that way, we can do it 3 times 2 plus 4 times 3. Remember, this would still be 3 right here. And that was going to equal 6 plus 12, which is going to equal 18 as well. So that's just the geometric interpretation of the distributive property. So what we actually had was, we just showed that 3 times 2 plus 4 equals 3 times 2 plus 3 times 4. So that's what we showed. And using a general case with variables, if this is A, and this is B, and this is C, we can think of it, to find the whole area, we can either do A, B plus C, right? Or we can just add the shaded plus this to equal the whole thing. That's AB plus AC. Okay? So that hopefully that makes sense, and you can see why the distributive property actually holds true in a geometric sense. So that's pretty exciting. Now let's do one more thing. The final thing is instead of having A here, we'll have two numbers, and we'll see how that'll change things a little bit. Okay, so we just showed that A, B plus C, that equals AB plus AC. What happens if we have A plus B times parentheses B plus C? How would that change things in terms of the distributive property and factoring? So let's think about this for a second. You know, this is kind of a little bit harder. So before we had A was here, B was here, and C was here. Sorry, this should be a C and a D. Sorry about that. So before that was there, and now we have a different little picture where we have this could be C, this could be D, and we have A here, and we have B here. So we can see it's a little more complicated now, right? But this will illustrate the property that we're going to show. So again, this is just A times B plus C, as we showed before. It's right here. And how could we think of the area of this thing? Right? We can do the whole vertical part times the whole horizontal part, and that'll just be A plus B times parentheses C plus D. Right? That's this plus this, or we can add it piece by piece. So how would that look like if we add it piece by piece? So let's separate the pieces first so we can see. That's one piece, and I'll draw like little circles here. That's another piece. What could I do here? I'll leave one white, and then I'll do one like dashed lines. So we can see that it's made of 4 pieces that make the whole thing. It's made of this one, this one, this one, and this one. So let's add it piece by piece to get the whole thing and see what we get. So first I see this thing. I'm gonna get rid of that AC. So now I have to add this thing, and what's that gonna be? That's gonna be AD, right? And then let's add this thing right here. This thing is gonna be B times C. And lastly, we have this thing right here, and that's going to be, the D is this thing and the B is this thing, so plus BD. So right there we showed how to distribute if there's 2 variables instead of 1. In this case there was just 1 and then 2, and here we can see there's 2 and 2. So it becomes a little harder, but we can see that if we stick to this formula, it'll be great. And another way to think about it is we go here first, then we go here, here, and here. So let's practice it a little bit. This is just to show you where it comes from, and let's just try applying it. Let's do it with numbers, because that could help us just to see what's going on. So we have 3 plus 8, right? And we have, let's say, 2 plus 1. Doesn't matter. So let's try to draw this out. What would this look like in terms of a figure? So let's say make this 3 right here, and let's make this a little bigger. This would be 8. Okay? And this would be 2, very small. And this would be 1. And it might not be perfect drawing, but it gets the relative idea across. Right? So we can think of this as like the whole vertical thing times the whole horizontal thing, which is this times this. Or we can do it piece by piece. So I'm going to start, first thing we do is this thing right here, right? And that'll be this thing, that represents this area right here. So it'll be 3 times 2 is 6. Next, we go from here to here. And that represents this thing right here. So that'll be plus 3. Then we add this thing right here, which represents this. So that would be 8 times 2 is 16. And then we have this times this, which is plus 8. Right? So that just gives you an idea of working with numbers of what the distributive property means. So we geometrically showed how to distribute, and we worked with addition today. We'll work with addition tomorrow. But I really like these geometric interpretations because it gives me a conceptual understanding of what's going on, and hopefully you see this more as it makes sense now as opposed to just a procedure. And on one closing thing, you could continue to distribute. For example, if I had A parentheses B plus C plus D, plus E, that would still be AB plus AC plus AD plus AE. And if we draw a figure, we can see why that's true. Let's have A over here. And let's call this B, C, D, and E. Right? So we can think of it as either the vertical times the horizontal, which would be A times this whole thing, or we can think of it as the sum of the parts, which is AB, this thing, plus this thing, plus this thing, plus this thing. That's what this represents here. Thank you very much for the lesson today, and please review so you can understand. Thank you.